Good day, class. In this lesson, we will learn to solve quadratic equations using the graphing method. Remember, to solve a quadratic equation, you can use factoring method, you can use the square root property method, completing the square method, the quadratic formula method, or the graphing method. Today, we will learn to use the graphing method for solving quadratic equations. Let's take a look at a quadratic and talk about some of the features of a quadratic equation. Notice how every quadratic equation is a quadratic equation because the highest power of the variable, when a variable is raised to a power, is 2. So notice we have x squared minus 5x plus 4 is equal to 0. The highest power of our variable in this equation is 2. Therefore, we have a quadratic equation, and every quadratic equation has a shape like what you see here on your screen when we graph it. It's shaped like a parabola. Sometimes we refer to it as a U, but it has a curve to it. So we must recognize when we have a parabola, we have a quadratic equation that is associated with it. Or when we have a quadratic equation, the associated graph is going to be shaped like a U. Now that U will give us some specific information about the solutions for the quadratic. Notice how we have an equation here, x squared minus 5x plus 4 is equal to 0. Just like with any other equation, there is a value or values of the variable that make a true statement. That is the purpose for solving an equation. Well, with quadratic equations, since that highest power of x is 2, that indicates that there are 2 possible solutions. Notice how on the left, this is an example of a quadratic equation that has 2 solutions. Notice how the parabola crosses the x-axis 2 times. Those indicate the solutions of that particular equation associated with that graph. Also notice on the right how this given quadratic equation, or the quadratic equation associated with this parabola, has a single solution or one solution where it is crossing the x-axis at one location. Therefore, any quadratic equation even as the one you see here on your screen, x squared minus 5x plus 4 is equal to 0, has a certain number of solutions up to 2 possible answers, 2 possible solutions. This particular quadratic equation has a solution of x is equal to 1, and it also has a solution of x is equal to 4. In other words, I can substitute the value of 1 into that equation, x squared minus 5x plus 4, and get 0, or get a true statement. I can also substitute the value of 4 in for x and get a true statement. Because this graph crosses the x-axis at x is 1. This graph also crosses the x-axis at x is 4. Those are my solutions. The x-intercepts, or where the graph crosses the x-axis, are the solutions of any quadratic equation. Now, let's use function notation to help us use graphing as a method to solve our given quadratic equation. Here is the equation, x squared minus 5x plus 4 is equal to 0. Remember that this can be written, if it is a function, in function notation, where I'm going to use the main part of my quadratic equation, that x squared piece, that x to the first piece, and that x to the 0 piece, or in other words, that x squared minus 5x plus 4. I'm going to use that piece as the main part, and I'm going to set this equal to f of x, because that's going to help me when I am using graphing to solve this equation. It'll give me something to substitute in place of my variables x. So then I'm also going to, write it this way. Remember f of x and y can be used to represent the same portion of the equation. So I'm going to use this y instead. So I just want you to note that I didn't just rewrite the equation or change the fundamental concept of it. I just want to write it in a way that is convenient. So I'm going to write y is equal to x squared minus 5x plus 4. Same thing as our original equation, just from a different perspective, because I want to use that value of x to solve for a value of y. So in other words, I'm going to graph my equation. Remember graphing. I pick values of x. I'm going to start with x is 1. I'm going to substitute that value into my equation and simplify. And then it'll yield a value of y. Therefore, for this particular equation, when x is equal to 1, y is equal to 0. That is a coordinate point that falls on the graph of this equation. I'm also going to substitute 2. I'm going to check for the value of y when x is 2. As I simplify, I discovered that when x is 2, y is negative 2 in this given equation. I'm also going to keep moving forward and substitute the value of 3. When x is 3, what is the value of y? I'll continue to substitute, simplify, and yield new values each time. Keeping it going, I'm going to substitute the value of 4. Determine what is the value of y when x is 4. In this case, I discovered that y is 0 when x is 4. Now I'm just going to check one last possibility just for kicks, and I'll substitute the value of x as 5. When I substitute, I can simplify, and this yields when x is 5, y is 4. And so now I should be ready to graph these coordinate points onto my coordinate plane. But 2 points should jump out at you. The x-intercepts, or the place at which y is 0, because that's where the graph crosses the x-axis. Whenever we took 0 steps on the y-axis, then we are sitting on the x-axis. Therefore, these 2 points in particular I want to graph because these are actually my solutions. The solutions are where the graph crosses the x-axis. Now, someone discovered this, some genius, many years ago, and we're very thankful for that. So just keep in mind, the point is, if you can identify where the quadratic equation crosses the x-axis, an exact value, that is the solution to your given equation. So I'm just going to go ahead and graph a couple of other points, again, just for kicks. And so now we see the parabola, and we can also see the solutions to our equations are x is equal to 1 and x is equal to 4. Let's go ahead and double check these solutions. This is the equation back to 0 is equal to x squared minus 5x plus 4, which is our original quadratic equation, and we're suggesting that the solutions are the answers that make this a true statement. The only answers in the universe that can make a true statement here are x is 1 and x is 4. So we'll check those to make sure that we're right. So I'll substitute 1 into this equation and see if I get a true statement. I do. That means my answer is correct and I've successfully graphed my equation and discovered one of the answers. Let's check the other solution. X is equal to 4. Now I want to go with substituting 4 into this equation to see if x truly is equal to 4 to make a true statement, and I discovered that it does.